So this is what it looks like in Flask 0.10, which is actually not yet released, but I want to get around this next week around. Flask current app is bound to the application context. So once there's an application context, you can figure out what's my current application. Flask.g, as of 0.10, is also bound to the application context. And request and session belong to the request context because they kind of go together with what is an HTTP request. And roughly it works like this. Application contexts are really fast to create and destroy, so you should be using them if you don't need the HTTP request. And if you push a request context, you implicitly also push an application context. So if you have used the with test request context construct in the past, it will now magically also create an application context for you. And G binds now to the application context. Now, this is just a rough overview of how this whole state management in Flask works. The rest of the presentation kind of assumes that you have a rough understanding of how these things go together. So as of Flask 0.10, or in a limited degree as of Flask 0.9, all the resources are supposed to be bound to the application context. All right, so this is roughly how it works for resource management. You create and destroy an application context every time you do anything. Out of the box, if you do handle an HTTP request, so if you have an app route, it will automatically create and destroy a request and application context for you. So you don't even have to deal with any of this behind the scenes stuff. However, not every HTTP application is actually just responding to browser requests. A good example is you have a script that creates your database connections, your database tables. And for the duration of that script, you want to have a database connection, so you can actually modify something. In that case, you can create this application context, and then you have helper functions that will populate a database connection onto this application context. And then you do something, and when you destroy the context, it will automatically destroy all the connections that go with it. So in order to see how this works, there's a little bit of a code example. I hope this is somewhat readable. If you create an application object, there is a decorator function on it called teardown app context. And this decorator can be used to register function callbacks with the application. And every time the application context destroys, all of these functions are executed. In case the execution works without a problem, it will be passed none, so to indicate there's not an error. If it tears down because of an exception, there will be first parameter called error in there. So if you create it by hand with the ctx equals app context, and then push it and pop it, you can see the teardown handler was executed with no error. If you do it in a with block, and that with block terminates with an exception, because for instance, in this case, it's a division by 0, you will see that it did tear down with an exception object. Now this is a very useful general concept. So the teardown handlers are always called if you pop the application context. Now in Flask itself, that automatically happens out of the box at the end of the request. So one thing you can, for instance, do is you can bind your database connections automatically on first usage. So you can have a function called getDatabaseConnection. It will check if there is already a database connection on a G object. If there is no connection on it, it will create one and it will remember it, and then it will return that connection. Now at the end of the request, it will do the same thing. It will check, is there a database connection? And if there is actually a database connection, it will close it or return it to the pool. So in this case, the first time you actually use a database connection, it will remember it, keep it around for as long as necessary, and then when you destroy the context, it goes away. And this resource management can be further improved from there. For instance, for database connections that are traditional relational databases, there are two cases. One is I want to commit my stuff. The other case is I want to roll back. There was an exception. You can automatically do this because the error is passed to the cleanup function. So in this case, if there is an error, it will, if there is not an error, it will commit, and if there's an error, it will roll back, and then it will release the connection. Is this this general concept roughly? Have you used something like this with Flask before? All right, very low number of people. Sorry?
I think the Flask SQL already is next.
Right. So for instance, Flask SQL Alchemy does this behind the scenes automatically for you. Or other Flask extensions already couple these pieces of code for you behind the scenes so you don't have to deal with it. But the general concept is still very useful. For instance, if you use, how many of you use the requests library with Python? So fair enough. Request is basically similar to URLib, just that it has a nice interface. So you can do HTTP requests to other things. Now, if you do a lot of HTTP requests to the same server, you can reuse the TCP socket behind the scenes so that you don't have to do the TCP handshake over and over again. And requests will automatically do this for you. And the way this works on requests is you create a session object, and then you can keep that session object around. And for as long as the session object exists, it will keep the connections in there. So for instance, you can create a session at the beginning of the request, and then at the end of the request, you turn the whole thing on. This is something I use very often on top of SQL Alchemy in a slightly modified version, which is the idea of an on-commit callback. Now, imagine you have a shop. So let me just show you roughly how this works. It remembers a list of callbacks on the G object. That's basically what it does. Now, the way it could be implemented is that if the whole thing tears down, it will check if it does commit, and if it commits, it will get this, this list of callbacks and then execute each of these callbacks. Now, if you have ever written an application that does some sort of transaction processing, like an online store where you can buy a product, and then that product is bound to you, and you own that product. Your account owns the product. And then you want to send a mail to the customer that you now purchased this product in a store. Now, there is a small chance always that your database will not go through properly. So there could be an exception happening because you lost your database connection, or there was some sort of other error that was happening. Now, one thing you don't want to do is you don't want to send the mail out to the customer that he owns that product before the product is actually in the database, because that doesn't leave a very good experience with the customer. But because the commit happens at the end of the request, this is actually happening outside of the scope of your function. So in the purchase function, if you would send direct, so you have two options. The one option out of the box is you commit your transaction in there, and then you send the email. Option two is you send the email and then return from the function. In which case, if an error happens afterwards, the customer already got the email that he owns the product, when in reality it was an internal server error. Now, if you have like this small little after commit decorator, one thing you can do is you can update your database. So in this case, this would SQL Alchemy be, and it says append my product to the number of purchased products this user has. And then it will remember a function to execute when the transaction commits, after the transaction commits. In this case, if the commit actually went through, if the whole thing tears down, it will send out an email for you. So this is just one of the things you can do when you have a list of callbacks on the current request. So you can defer code execution until the point where you're happy with it happening automatically. The second thing I want to talk about is response creation. Now, if you use Flask by the tutorial, you don't even know that there are response objects being created, because one thing you do is you write a function and it returns a string, and then all of a sudden there's an HTTP response. The way this works in Flask is it will automatically create one for you. And you can replace this response object over and over again with other things. But the important part is there is no Flask.response. What is there actually is there's a response class you can instantiate, or is automatically instantiated for you. So I suppose you have seen this example. It's a function that listens on slash, and it renders a template and then returns this. So where is the response object being created? Render string, render template returns a string. Now what's happening is that Flask internally on the main object has a callback function that's executed, which will check the return value against a certain number of types, and then if it sees a type it recognizes, it will automatically create a response object for you. So the default behavior is if you return a string, it will create a response object for you with that string as a body, 200 OK as an error code, or status code, and then text HTML as content header. So what do you do if you want to add a custom header to this? Option one is you do this. You import the function make response, and then you wrap your return value in with that make response, and you get a response object you can modify. Alternatively, you can, like in Django, create the response object yourself by hand and then modify it. And then return it. The other option you have is you can actually customize the behavior of how Flask will create response objects for you. So one example here is if you do a lot of APIs, you might return a lot of JSON objects. One thing you could do is you could say, all right, if I'm returning an object from my function, and that object has a certain function on it to automatically convert it into JSON, it should automatically do this. So for instance, this would be a custom Flask subclass, which overrides the make response function, which is provided by Flask internally, and it will check, is there an attribute called toJSON on it, and then we'll execute it, and then it will automatically create a JSON response. So then all of a sudden, all of your function changes. You can directly return a user object from the function, and will automatically create a JSON response for you. Now the reason why this is interesting is because one thing you can trivially do is you can do your unit tests now based on the objects you're returning, instead of actually looking at the whole HTTP response. So in your unit test, you can just execute that init function, and it returns a user object, and you can check if the user object looks like what you expect it to be. So you can do some very improper testing this way. You should still do testing on actual return values from an API, but it might make sense for a certain number of applications. All right, the next part, which is one thing I like a lot because of how interesting things you can do with very little work, is server-sent events. Now, I want to know how many of you are actually doing some sort of, in quotes, real-time application where user interface updates based on changes on the server side automatically. All right, that's not a lot of people, so maybe there is something interesting here in this one. Do you know the concept of a server-sent event? It's a feature of HTML5. It's also called event source. Maybe it goes by that name more.
Sure.
It's similar to server push. It's a very trivial way. It works with any Whiskey server. It works better with some others, and it's basically it's getting real-time applications with real-time quotes with basically 20 lines of code, and it's ridiculously simple. So roughly, this is how it works. The client opens a socket, and the server sends data and then 2 new lines. So data colons, white space, then any string, and then 2 new lines. And then every time the server sends this, the client is automatically updated. So you basically just keep the socket open for a really long time, and then JavaScript code can read from the socket. You could obviously do this before event source, but event source gives you a nice API for it. This works really well with G-Event and G-Unicorn as your Whiskey server, because one thing they do really well is keeping tons of sockets open. If you use a more traditional web server like mod WSGI, every socket you keep open keeps a kernel level thread around, so that's quite expensive. But one thing you can nicely do with this is you can have one part of the application being served by G-Unicorn, the other application being served by, well, maybe also G-Unicorn as well, but you could also serve it through mod WSGI, and then you put Nginx on top, and then you unify these 2 very different concurrency models. So I don't know if you have noticed this, but G-Event is a really bad choice if you want to do databases. Because if you keep a high number of connections open to the client side, and each of these connections keeps their connection open to your database, then all of a sudden Postgres will terminate because you have too many database connections for Postgres, for instance. But that problem does not exist if you do your traditional application that talks to the database in with like 20 workers and mod WSGI, or 20 workers at G-Unicorn. So the total number of database connections to a database is capped to 20, and then you do like the high concurrency to the client, where you have like 2,000 clients sitting there waiting for the socket with Unicorn. So then this is basically how you can do server-sent events with Flask and any whiskey server in what I would assume is like 15 lines of code. You make an endpoint called streams interesting, for instance, and in there's a generator, like a regular Python generator, and here I'm using something in Redis called subscriptions, or PubSub. You create this PubSub object, and then you say, I'm interested in this interesting channel. And then every time there is an event in this channel, and the event is of type message, I'm sending this to the client. And then the way you create this response is you use stringless context, which is a function in Flask, which will just keep your context objects around for the duration of this generator. And then you say direct pass-through equals true. That's necessary so that no buffering is happening anywhere along the way that would destroy this behavior. And then you set the MIME type to text event stream. And so now all you have to do to notify a client about a change on a server is you have to put something, you have to publish something to this Redis channel. So you have another function called create something, where you create that thing, and then you publish a notification that you create that thing into the interesting channel. On the client side, all you have to do is there is a function called event source, and every time event data is in that stream, you get a function call from JavaScript. And this, you can do this arbitrarily complex. You can have one channel per user, you can have one channel per interest group. So for instance, one thing you can trivially do is you make a paste bin, and each paste has, so each piece of code you upload has a unique ID in it. So you have one channel for each of these IDs, and then every time an update comes in on that paste, because someone added a comment or did a modification on it, you just send an update into this Redis channel, and everybody who is listening on it will automatically see, hey, there was a modification on this. So this problem that why people typically did not necessarily do that with Flask was that, as mentioned before, GUnicorn is not a good idea for like a user space concurrency model. That allows you to have high concurrency is a bad idea to mix with a database. But if you look at what this actually does, the only database access that's happening here is Redis, and Redis is optimized for high concurrency. Well, it's really fast for high concurrency. So nothing in here is doing anything with the database. So it does talk to Redis, but calling Redis a database is quite a stretch. So nothing here ever authenticates a user. Nothing here connects to Postgres. So this part you can trivially keep in GUnicorn, and the rest you keep in UWSGI. So this you can achieve by doing some very basic worker separation. The way you do this is you have a supervisor config, and you start the application twice. Once you start it up with four processes, and then listen on port 8000. And then you start it again 4 times, but with the G event worker, which is optimized for high concurrency, on a different port. And then all you have to do is you have to go to Nginx and say everything below streams goes to the one that's high concurrent, and the other one goes to your regular server. And then you get all the benefits of a real-time updating the application with basically, at the end of the day, maybe 30 lines of code, and you don't have to throw away anything. So do you have a rough overview of how this concept can be applied, or any confusing parts here? Well, I take this as a yes, I suppose. The one thing I really like, which I don't know why I haven't started using this before, but this is probably my most favorite piece of thing or idea or concept I have seen. I know a couple of years ago, which is the idea of you don't actually store anything, you just pretend it's there, and you send it around over the wire, and you just make sure nobody modifies the data. So you know how, for instance, user activation usually involves sending someone a random number, and then that random number has to come back, and if that random number comes back, so the authentication code, then it activates a user profile. I suppose you have written this before. It's on sign up, you send your user an email, and that email contains a link, and if you follow that link, your user account is activated. Now, the downside of this is you have to keep all of its codes around. So each user can have this code redeemed once, and when that code is redeemed, it should activate the user account. Now with the user account, it's simple because the number of users you have is finite. Every user can only have one of these activation codes, so you just remember that activation code anyways. There are certain things that you do in computing that generate many more of these tokens. A good example is OAuth. Now with OAuth, every time you authorize against an endpoint, you generate a piece of token. Now there are two options you can do this. You can either remember those tokens and then maybe return the same tokens over and over again. Option 2 is you create an infinite number of these tokens and you don't remember them. You just remember how to validate them. And the way you can do this with Python is with the It's Dangerous module, which is basically just a re-implementation of how this works in Django, just that it doesn't depend on any of the Django internal stuff, and it simplifies the interface of how you can actually use this for signing. So basically, it saves you from storing stuff in your database. You just send a piece of information across on the internet, and you verify at the end that nobody tampered with your data. For small tokens or other things. In fact, if you use a session in Flask, that session is not stored on the server. That session is sent in the cookie round, and it's just signed that nobody can modify this cookie. So if a user sees, like if you store is admin in your cookie, nobody can flip this to true or false because it would invalidate the signature. And the signature can only be generated by the server side because it requires a piece of knowledge, which is a secret key, which the client doesn't have. So a very trivial way of doing that would be you create a URL-safe serializer of the It's Dangerous module, and you pass it the secret key. Now the secret key should be really, really unique. A good way to generate these secret keys is to use the OSU random function, which just reads a bunch of bytes out of your operating system entropy buffer, and then you remember that it's a config. And then you can further derive a modified key out of this by adding a little bit of salt, which is in this case random numbers again. Now, one thing the reason why you want to keep the salts separately is, for instance, someone leaked, someone lost his, someone leaked a little bit of information. You want to invalidate all of these links at the same time. So all you have to do to invalidate anything the serializer has ever created is to modify this activation salt. Then all the tokens ever generated are immediately invalid. And so the way you would do this activation link is you say to the serializer, dump me the user ID with the salt in, and then put it to the activation URL. So the activation URL can have a random number of bytes at the end, and this random number of bytes is it's not entirely random, it's the signature, and then after the signature there is an encoded payload. So your user ID, say, is 42, the activation link would be some random numbers plus the number 42 URL encoded. And then all you have to do to activate the user is you load that thing. If the signature was bad because someone modified it, you can abort with the 404, otherwise you activate the user with the ID. Now, in this case, the token is valid for an indefinite amount of time. So you can activate the user account 4 times. That's not a problem because an activate user account cannot be reactivated. But if you want to do this differently, you just need to put more information in the token. For instance, one thing you can do is you can not just store the user ID in there, you can also store a timestamp in there. So you would serialize the user ID plus the timestamp. Then when you activate it, to check if the timestamp is still within the realm of what's reasonable. So for instance, you would not activate the user if the link is older than a day. If you really want to go to the point of where you only activate it exactly once, you could store a piece of information in the token that you can then validate that it actually changed. What I mean by that is, for instance, password changes usually have a string you send to your user, click the link, and then you can change your password. The way you could do this is by putting an MD5 hash, a truncated version of the MD5 hash of the password of the user, into the activation link. So if the user actually changes the password, that hash changes, and with that, the link becomes invalid. So that would be one option to put more information into the serialization system. Have any one of you ever used something like this? You can instead of storing on layers. All right, fair number. If you don't want to use the asynchronous module, so I know a lot of you are doing Django. What is called Django util signing? It is. So Django util signing is a module in Django that roughly works the same. It's a little bit more integrated into the Django config, so you don't have to set up your own secret keys. It loads the one from the Django config. But yeah, if you use Flask, the current versions of Flask depend on this module, so it's automatically available. Just import its dangerous, and you go ahead and sign stuff. It's really simple to do. So the last thing I want to talk about is customization in Flask itself. Now, this does not really correspond all that much to other frameworks, I suppose. But the way Flask is written is every single function that doesn't have an underscore in the front is intended so you can actually override it. So you can go to your application object and say, I want to override the way, for instance, responses are created as shown before. So you have a make response function, you can modify this by overriding it. Unless a function is marked especially as don't override or has a leading underscore, you can pretty much customize any sort of behavior here. I don't have any plans of changing anything of that sort. So everything that you see in the documentation is you can override it, just override it. It's not just functions that you can modify this way. There are also hook points directly in Flask that let you customize behavior. A good example here is, you know how HTTP caches can be quite annoying and just keep your static resources around for way longer than you have anticipated? A trick that comes up quite often is you put a random number of strings at the end of your URL, and then because the URL changes every time you do a server update, all your resources immediately become invalid. But you have to remember that every time you generate a URL to this static resource, you actually put this random number of strings behind it. So one hook point, for instance, in Flask is URL defaults, which is a function. You can register a function that will be executed every time you generate a URL. So for instance, in this case, it checks if the endpoint is static, which is what my static files are. I put an underscore v into the URL variable, which is the asset revision, which in this case would be an MD5 hash of my current package's version. So every time I do an update in my setup.py that increments the version number, it will automatically put a different revision hash at the end of my files. So if you do a URL for static file name is something, it will automatically get a question mark underscore v equals random string. So at that point, you no longer have to worry about it. You just do a server update, and all your static files get a different revision at the end. And there are many more points where you can override behavior within Flask to customize certain use cases. The obvious ones are all the function decorators, but you can just override pretty much anything. For instance, one thing you can do in Flask is you can replace your request and response object to different implementations. So one thing more and more people are discovering is that Flask will automatically parse your form data, which is useful because you get your form data out of your request, but sometimes you want to interface with a library that has very specific requirements on the request data. So for instance, I don't know, have you ever used PayPal? Integrate with PayPal? They have this really annoying API where the order of incoming parameters matters. So there are ready-made libraries that already deal with this, but when Werkzeug, or for that matter Flask, parses your input data, it will be put into a dictionary, and as we all know, dictionaries lose their order. So one thing you can do is, for instance, you can, if you want to interface with something like this, you can just subclass the request object. You say, I don't want my form data parsed. There's a parameter on it, customizes behavior. And then I also set data to none. I will explain a bit, and then register with the Flask object. Now, every time a request comes in, it will be of that custom subclass, and because the flag when form data parsed is flipped, it will not actually parse your form data anymore. The reason data equals none is here is there's a default property on the Flask request object called data, which if you access it, will read all your data to a string, which can be quite annoying, especially if that incoming data is quite large. So you can just disable it by saying data equals none, and then you will don't accidentally read all your data into a string. So yeah, there's a lot of customization hook points in it. every time you see some sort of behavior you wish it would be different, check if there is already a way you customize this behavior, and if not, put a feature request up for it, because I don't like the idea of having to run a modified version of a library with diff files and everything. It should be possible to customize this out of the box to the degree necessary. This is just a little bit of extra thing in there, which is probably too large to have on a slide, but the idea of redirecting to an arbitrary domain is quite risky. So you know how most websites have a login form and then it redirects you somewhere? The typical trick is to have a next parameter in that URL that says, once you signed in, go back to that whatever step you came from. Well, if someone puts disney.com in there and you will sign in, you will then be redirected to disney.com, which is something you probably don't want your user to be redirected to. Disney would be quite obvious for a customer to see that this is actually not the website I want to end up on. But if someone puts a website in that place that looks exactly like your website, just a slightly different URL, it's a very nice way to fish off users' credentials. So a very simple way to do this, but unfortunately way too large for the slides, is to have this concept of a safe URL function. So the way you can trivially do this in Python is you have this URL parse module, which parses URLs into small parts. And then you parse your request URL, and then you parse this against the URL that's being passed in. And then you check if this is actually from the same host as your request. So if this is on a different machine, it will return false, so it's not a safe redirect. And then also, one thing that's quite annoying is if people actually are on the password reset page, and they do something with it, and they manage to create a redirect loop, because the page redirects to itself. We want to avoid this as well, so this is a simple function that checks if it's a different URL, and if it's a different URL and it's a safe URL, this redirect back function will return back to that page. Otherwise, it will go to the fallback. The fallback, you could, for instance, in this case, you can say return redirect to URL for index, which means it will redirect back to the page you came from, or if that page is unsafe, or that page is actually the same page as you're currently, or I don't know where to redirect it to, it will redirect to the fallback. I want to put this into PyPy somewhere, but it's like this is really all that's necessary, and you have safe redirect thing going on. The other thing is, here it does request args get next, which if you change this to request values get next, then it will check both the URL parameters as well as the phone data. So one thing you can then trivially do is you can remember that next target in your form. So every time the user does not remember his password and attempts over and over again, it will not actually lose where the user is being redirected to. You can then even go further and say, oh, and I have forgotten my password, and you put that next URL in there, and so the user never actually loses track of where he was on this website. All right, that's as far as patterns in this presentation goes. I am more than happy to have an extended Q&A in regards to whatever questions you have. And then otherwise, thank you for having me.
Does anyone have questions? Raise your hand if you have a question, please.
Microphone or?
Try to speak loud.
In a tear-down context decorator, that function one. Could I suppress error propagating and raising exception after tear down?
You mean, can you terminate the request with an exception, with an error at this point? Or
no, he tries to say that can he suppress...
Oh, okay. So the question is, I think, if you can, from this teardown decorator, suppress an error that would otherwise be generated by response. So if any of these, so there are two functions. One is teardown. Teardown functions are executed when you destroy your application context. Now this concept generally does not correspond to an HTTP request. So while it might often occur as part of an HTTP request, there are other reasons for this to happen. There's a second function called after request, which will get the same parameters, but it will not be executed if there's an error. So that is one way to customize behavior. The third option you have to customize, especially the error case, is there's a thing called app error handler, where you can pass in an exception object. And then every time an exception of that error is being created, you can return a different response. We are, for instance, using this if we have an internal exception called service unavailable, which is raised by database connections not being there or anything of that sort, which will then automatically be generated into a nice user visible, oh sorry, we're in maintenance mode error. I can see if I actually get a browser up here. That's huge. Just to give you an overview of where this would be. Oh my goodness.
Too much R in our error.
So the same way you can have a 404 in here, you can also put in any exception clause in there, if that loads. So you can have like a database error and then return something else. Yeah. Yeah.
Armin, I have a question about signing. If you have to change your secret key, for example, it's not so secret anymore. And if you have URLs, they don't work. What's a good practice to change secret key?
So for starters, the most important part there is don't lose your secret key. Which sounds hard to do, but actually the majority of people don't lose the secret key. Now there is this one case that comes up very often, that's actually the only time I've ever heard a reasonable reason of why you lose your secret key is because you have an open source project and you put your code to GitHub and your secret keys in there. So for that reason, I strongly recommend loading the secret key from a separate file, which is in your git ignore, and you don't ever put this anywhere. So the most important part is don't lose your secret key. Now if you did lose your secret key, change it as quickly as possible and make up a press statement that says why your URLs are broken, I suppose. Because if you would support the old key still at that point for a grace period, that would be obviously not a possibility. So one thing you could do is every time you load in your signed data, you have a list of keys. So you know the old key is still valid for 5 days, so you try to read this first. You try the new key first. If that fails, you try the old key, check if the old key is still within the grace period, and then you load the old key. The problem there is that it's really juggling with burning things, because if your secret key is known to be leaked, then they can pretty much modify anything of that signed information, which is a huge security risk. So at that point, I would not have a grace period. I would just make sure I don't lose the key again and deal with broken keys. Now, the obvious result of this is that every time I have anything signed, I have a way to regenerate this information if necessary. So if a user password reset link becomes invalid because I had to change the secret key, there will be a link somewhere on the website where you can do this again. Same thing with OAuth tokens. If I expire your token or if I invalidate your token, there is a way for you to get a new token. So I never put anything into a signed piece of information which I couldn't by other means regenerate. So yeah, that's my recommendation in regard to keeping a secret key secret.
Okay, more questions?
Yeah.
Armin, as long as I used Flask, I always had a question about why we need an application stack in the first place. In most use cases, we don't need more than one application that is associated with the current request. Aside from, as you said, unit testing, can you thought up any scenario where we'll need to use more than one application and in stack manner?
So the reason why you would want to have more than one application in the absence of unit tests is actually in the documentation under the pattern sort of thing. I just want to bring this up because it actually shows this quite well. Where's this? I think it's in here somewhere. So one case, I think it's in here somewhere. Well, this is quite confusing to see, but it shows a little bit. So one example of where it's interesting to have more than one application is if you have multiple customers.
No, sorry, I didn't phrase my question well. I understand why we'll need more than one application. The question is why we need to use a stack for this.
Oh, why there's a stack instead of just the information? So the reason why there's a stack instead of just a spread local is mostly sanity. So you don't actually accidentally leak something out. So if there wouldn't be a stack, and so the push context do something with pop context guarantees isolation for starters. So you don't so one thing I had with spread locals before, why I hated them, is you run your thing and then you don't clean up properly and you leave a reference to that stuff you did before hanging around, which is especially bad when it comes to multiple users. There was an exploit against one Python framework where the thread locals were not cleaned up properly. So if you knew what you were doing, you could go to the right endpoint and you saw the last user's account page, because that user was still sitting around on a stack. So the stack solves, first of all, it very clearly terminates the lifetime of this information. And secondly, sometimes you want to do internal switch to other user. So this is why I want to show this example here. Is we do this sort of in our code base, just not directly in the whiskey level. We have multiple customers, and we have one application which is special, which is an internal application where you sign in with a special user account, and you can create more application yourself. And this special application switches context to that other application as necessary. So you sign into this management website, and then you maintain other websites. And some of these API calls have to modify data in another database. So they will temporarily switch work over to that other application, do stuff there, and then destroy it. And this is very easy to do with a stack. It's not as easy to do if you have to keep the reference yourself. So it's just a built-in sanity system, sort of.
More questions, please?
Yes, Armin. My buddies are curious. Do you want to port a Flask to PyConRu for next year?
Well, there's a work being done by someone to do a Werkzeug port to Python 3, which is really the only thing that blocks it, because Flask itself, if you import it on Python 3, if it wouldn't be for some syntax errors, it would work. Because Flask is so high level that the Unicode problem is solved. It already speaks to Unicode in Python 2, so nothing really changes there. The problem is Werkzeug itself, and the main problem there is I'm not using Python 3 myself, so I didn't have much of a motivation to actually port it over. But yes, someone is working on it, and I want to see if I can merge this in soon-ish. So to be honest, my main problem of why I haven't done any work on this is I have in my mind that that number might be wrong now, but certainly last time I was looking at the vast majority of users that would use this thing are running on Python 2. Now because the Werkzeug library is so low level, it did make certain assumptions in regards to how Whiskey works, which are no longer true in Python 3. So the moment I do a port to Python 3, I will have to break the API for Python 2 users if I want to have the same overall experience. At which point I will annoy a bunch of users to have to change their code for what appears to be not a good reason. So I don't have a solution for this yet. There was a port at one point which I could have merged, but that would actually have caused Unicode problems on Python 3. There's another port that somewhat done, which changes API for Python 2, and it's basically a matter of finding a nice migration path for everybody to deal with the new API really. Because there will be, like the moment the Python 3 patch lands, there will have to be changes for Python 2 use as well. And that's the main reason why there's no port currently. But yeah, I mean, the port will happen, that's for sure. It's just when is the right time sort of thing. If all of a sudden there are tons of Python 3 users, or let's say I want to go to Python 3 now, a really good reason, then that is a good reason for me to make a port. So far it always has been, yeah, Python 3 is nice, but I'm actually using Python 2. So, yeah.
Yes. More questions, please? Good? Then we are done.
All right. Thank you.
For 15 minutes. And thanks again, Armin.
The slides will be up on our website, so if you want the code examples, just go to my website or Twitter feed. It's linked from there.